Welcome everyone. Today we're going to take a look at some advanced series circuits, and that's because in the circuit that you notice on the screen, we do have two bulbs that are connected in series with only one path. However, they do not have the same amount of resistance. And so we're going to take a look at what kind of implications that's going to have. Now, first off, notice the values. I have a 10-volt battery, a 5-ohm lamp, and a 20-ohm lamp. If you click values off to the side, that will show you what those are, and it will allow you to change them as appropriate. So make sure that you do that if you're trying out the virtual lab for yourself at home. Now, if we have two lamps that are in series, we would normally expect that they would split the battery voltage. That's a concept that you should have picked up from last week. However, in this case, they are not going to split it evenly. Many folks think that the first lamp is going to get 5 volts and the second one is also going to get 5 volts. That would be true if they had the same amount of resistance, but they don't. So what we're going to do is hook our voltmeter up to the first lamp, and we will notice that it actually only gets 2 volts. Where do we get that from if we weren't able to use the voltmeter directly? Well, the answer lies in what percentage or what fraction of the total resistance lamp 1 has. Now, in the system, there is a 5-ohm resistor and there is a 20-ohm resistor. Together, that means there is a total resistance of 25 ohms in the system. Lamp 1 is only 5 ohms. That means it's 5 out of 25. If you were to do that on your calculator, 5 out of a total of 25, that's 1/5, or 20% if you prefer percentages. If we were to take a look at our battery, which is 10 volts, and we took only 1/5, or 20% of that battery voltage, it would indeed be 2 volts. So that's where those 2 volts come from. If we keep that logic going, if we take a look at our second bulb, it is a 20 ohm resistor. That's 20 ohms out of the total of 25 ohms. 20 out of 25, that's 80%, or 4/5. Well, 80% of a 10-volt battery is 8 volts. 4/5 of a 10-volt battery, also 8 volts. So now let me take my probes and I'll put them on either end of lamp 2, and I'll notice I have 8 volts. So it was 2 volts to get across lamp 1, 8 volts to get across lamp 2. That makes sense. 2 volts plus 8 volts is the total of 10 volt from the battery. They still did split the battery voltage. They just split it unevenly. More voltage was required to send the current across lamp 2. That's because it had more resistance. And to keep the current the same, we needed a bigger push or a bigger voltage to get through the second lamp. So let me put my voltmeter probes aside for right now, and we're going to take a look at the second half of this, which was to find the current passing through each bulb. I'm going to use my non-contact ammeter and just hover it over the first lamp, and I'll notice I get 4 amps. Well, how did I come up with that value? Well, the key lies in Ohm's law. If I hook my voltmeter back up to the first lamp, remember it was 2 volts. Ohm's law says V equals I times R. We want to find I. Rearranging that formula to find I, or the current, gives me voltage divided by resistance. So if I take the voltage, 2 volts, and divide it by the resistance, 5 ohms, 2 divided by 5 on your calculator, you're going to get 0.4. Now, this is a series circuit, so if you use your logic here, you might notice that it has to be 4 amps everywhere in the circuit, including through the second bulb and the switch. Let's test that out using Ohm's law at lamp 2. If I hook my voltmeter up to the second lamp, I'll notice that I get 8 volts. 8 volts divided by 20 ohms in your calculator, you better believe you're going to get 0.4 amps as your current there. And to notice it works out the same way. I'm using the individual voltage, not the total from the battery. Let me put my voltmeter away, and I'm just going to hover my ammeter over the switch, and notice that even at the switch, the current is still 0.4 amps, and that's because it's 0.4 amps everywhere in the circuit. It's a series circuit. Hopefully this showed you a little bit about how series circuits work. Note that the bulbs split the voltage from the battery, sometimes not evenly, and the current is the same everywhere.